Mr. Srinivas Khandula is a very much experienced software professional. He has experience of 18 years in management of software technologies and software developing. And he obtained his MTech degree in the subject of computer science and technology. And presently he is working in VMware software technologies. Okay. He published many research papers in SCI Index journals and Scopus Index journals also. He has a patent in his name also in the subject of cloud computing and observability domain. He has working as a engineering manager for the VMware Tanju observability webfront SaaS product. He is working as a team leader of many software developing teams also. I hope that our young researchers will learn many things from him. He also loves to play with new technologies, and his hobby is to create new software platforms by using the new technologies what is going around in all over the world. Okay, I hope that all our participants will learn many things from him. With this small introduction, I welcome and invite Mr. Srinivas Khandula to present his lecture. Over to you, sir.
Hi all. Hi everyone. Thank you, Professor Prindis sir, for the introduction, and thank you all for providing me an opportunity to talk to you all and share my experience. Special thanks to DC Nath sir, Professor DC Nath, Professor C.R. Bhattacharya, and Professor P.K. Dev Sharma and Rakesh, and all the facilities, Rakesh sir, and all the facility members of Department of Computer Science and Assam University. Thank you all, and thank you all for here to listen to me. Okay, that said, I'm Srinivas. I'm going to share my experience and knowledge with you all in cloud computing. Let me share my screen. Tell me. Can you all see my screen?
Yes.
Yeah. Thank you.
Yes.
Yeah. Perfect. So today you will be getting an idea of what is cloud computing and how this is being used in the industry and by the businesses, by the organization across the world, what it is and how it is, the parts of it. Okay. This would be my agenda. I'll be giving an introduction about what a cloud computing is and who are the providers, what are the services that are in the cloud computing, the virtualization which is behind the scenes, the pillars of cloud computing, and the containers, Kubernetes. These are the new jargons that the industry is behind, and I'll be giving you a glimpse of all these things. The serverless technology and the microservices with Spring. And I would like to plant seeds in your thought process wherein you will go after this session, try to make them into trees with fruits or flowers. Okay, that's my aim. Coming to what is cloud computing? Many of you who from past 2 years are staying at home, and myself, like many of my colleagues, are working from home. And did you have a thought how this happened without even a downtime or without getting a lot of issues, right? How one could do this without any issue with the pandemic on. No one is going to offices, but still most of the businesses are running. No one is going to universities, no one is going to schools, still the schools are running. Many of the schools are running. I should not say all, but many of them. Many of the universities are running. You people are able to take the classes, and then you're conducting more webinars, right? All these things. How this is happening? This is because of the cloud computing behind the scenes. What is cloud computing? It is like you ask, it's a software. Cloud computing it's a software with UI and a backend and a network, which helps you to buy the resources online, your compute resources like the CPU, storage, the memory, and whatever. There are many services that a cloud computing that can give. The basic things like what you need to run a program is a virtual machine, a machine with a CPU, memory, and the storage. This, if you can get it from the software itself, that's a more advantage, right? You don't need to go to a shop and buy a powerful machine, a powerful server, and keep it with you, next to you in a AC room. And then you keep updating the software, you keep maintaining it. You don't need to do all the stuff. You just need to have one credit card, access to the service provider, and you just swipe your credit card and get your computer online within a minutes of time frame. So am I audible? I just want to double check that things are fine from my side.
Yes, sir. You are quite audible.
Yeah, perfect. So that said, thank you. Thanks for the confirmation, by the way. Yeah. So why people are behind this? Why people are behind this cloud computing? Because it's very efficient, it's flexible and strategic. How is it? It's like efficient in the sense like you can do everything in a very short span in time. You don't need to wait for some things to happen. It's very flexible. Like if you buy a compute power online, if you are done with your usage, you can just say that I don't need now. And from that time that you say I don't need now, you will not be charged. You will be charged for the time being on what you have used. For example, if you buy the same thing, hardware, and then keep it with you, what you have to do is you may be spending the electricity, you need a AC room, you need an admin to manage all the stuff, right? Even though you may not be using it over the night, you still spend some money on it, incur some money on it. So that's a flexibility that you can get. So for example, many of you might, after your PhDs or maybe after your MSc degree completion, you may go out and some may think to start a startup, right? In that case, if you have to spend your time on buying resources and connecting it and making the resource available to all your employees, it takes time. You don't need to do all that stuff if you have a cloud computing provider with you. Associate yourself with a cloud computing provider. You just go sit somewhere in your coffee shop, have your colleagues next to you, tell them that what do you want? I need a computer with this much memory. You go swipe your card, get the system, give it to him in 5 minutes of time frame. You can access the same computer which is sitting next to you in the same way which is sitting somewhere in the world. You will never know that where that computer has come from, but you still be able to access in the same way. The networking technology has improved a lot such that you don't feel the lag on them. You can do magics with this technology. So how does it work? It itself runs on a computer, which is a data centers, which is somewhere in the world. Some systems can be in Australia, in US, in Bombay, in Delhi, even in Bangalore, somewhere, anywhere in the world. But they are interconnected with very powerful high-speed networks, satellite networks, underlying fiber optic networks. All these form as a network, and then they provide you the power of computing. And they don't need to, you don't need to physically see them. Everything is via software, you can achieve that. And there are multiple ways of cloud computing. Everything cannot be one type fits all. There are different types of organizations, different types of software development happens. Some are like public, like I develop an application, mobile application, and I don't bother where it is, whoever access it, right? And you can deploy that application inside any of the publicly available networks, but that has security around it, but minimal anywhere in the world. But some organizations are there which, like banking sectors, government organizations, they strictly want their machines to be with them. They don't want to be shared across the other public people. So in that case, the service providers creates a private network, private data centers, and then they provide access to the organizations whoever wants to claim. And also the hybrid variety. Some organization, they can have some of their compute power be done in the public, and then something can be done internally in their organization, in their data centers, which is sitting in their organization. So this type are possible. And what are the types of services that we get? And the high level, there are three different types that cloud computing providers provide. One is IaaS, it's like infrastructure as a service. PaaS, platform as a service. SaaS, software as a service. If you group all the services, these services would fall into one of these buckets, I would say. So some of the examples are like IaaS is like you get plain hardware. It won't have any operating system in it. For example, you went out, you wanted to do a startup, and you don't know what software you are going to use, but you need a machine to run your program, maybe a basic Java program. You don't need a very high-end machine. You just need a small machine without operating system or something like. And you go to the service provider, ask him, I just need a 4 CPU with 4 GB RAM with 20 GB hard disk. He will provide you the machine IP with an access to it. And it's up to you to install, whether you want to install Windows or you want to install Ubuntu or whatever it may be into that. And that's a basic service that you can get from these service providers. But many of them may not be like that. If you are going for organizations where time is more critical, you would either go for a SaaS or a PaaS. PaaS is like platform as a service. So the service provider, he would give you what you want. For example, you go to the service provider and ask him, I need a machine that can run web application or that can run my Oracle database or a Tomcat server in it. So the service provider, he creates that particular software stack with the hardware stack and give it to you. And you don't need to worry about installation of Oracle server, installation of operating system, maintenance of operating system, upgrading of the operating system, or Oracle, or the backup of it, and the security of it. Nothing. You don't need to bother about all those things. You just get connected to that. You use it whatever way that you want. And much more advanced level is SaaS, software as a service. Like, for example, you're using Gmail, this Google Cloud. Do you think that your university has the infrastructure to run this Google Meet platform? No, right? None of the universities have. It's somebody, Google is providing us. So Google has invested its time to build this service, and then it is running the whole service. When I say service, it is a software application, multiple software applications working together to provide this service, right? Google Meet service. It has a video capability, audio capability, presentation capability, and a chat capability, lot many capabilities, right? All these things included this service. This is being developed by Google, and then it is being shared across. We all go and ask Google that, give me a service where I can meet with my colleagues, with my friends, with my classmates, with my teachers, and it provides you the service. You just need to ask it. That's it. I think many of you might have clicked single button, join this meeting. Behind the scenes, there's a lot of activities that went on, which Google did that, and then it's providing. That's one classical example of SaaS. Even your Gmail is a SaaS. Even your Amazon service is a SaaS, right? All this. I think too much of introduction. Let's go deep into the things. So who are the providers? Like there are Amazon. Most of you people may be knowing Amazon as a shopping site, but it has a shopping for compute service as well. Organizations can go and shop for their services. They can get services like a mailing service, messaging service, VMs, and storage service, and all the stuff. It's an enterprise grade service provider. Google, similarly, Azure, IBM, Oracle. These all organizations, they develop these cloud computing services and release it to the market so that we can buy them, like what we do shopping of clothes, shopping of whatever we want, electronics like that, right? These people are providing similarly the compute services. You go swipe your credit card, get whatever you want, assemble them, you build a software solution within minutes or within days. There are people who build within a day, less than 24 hours, a full-fledged application that can serve the customers. That's what the power of this cloud computing is. So let's talk a little bit about the services. There are many services. From the morning, I joined a couple of sessions, and there was a lot of talk about data mining, data, big data, and all. So I assume you might be running your data mining jobs inside your lab machines. The university might be having a huge lab, huge data center, where you are accessing those machines through either PuTTY or remote desktop or some other communicating mechanism, right? So similarly, the AWS, Google, and they provide these services, pre-built services, so that you don't need to reinvest in time. What's your job as a data science? You give it, you get the data, upload the data, run a job, get the output, right? Behind the scenes, there are many things. There's if you need a virtual machine, you need a storage, you need a compute power, CPU, you need a messaging service, you need a logging service to troubleshoot what's happening, you need a monitoring service to monitor your job. Monitor your job in the sense like how much time your algorithm is running. You want to fine-tune the algorithm. You want to know how much storage my algorithm is taking, how much CPU it is using, how much time it is taking to complete the process. All those analytics that you, as a data science, you don't need to do. You can delegate those things to these service providers, and then they will give you that. So my expertise is in monitoring and observability, where my software, the one on which I'm working, will monitor all these data centers and help the admins of these data centers to provide a 365, 24/7 support to all the customers. So it can predict that if a virtual machine or a hardware is going to fail, it can predict beforehand, saying that, okay, your hardware is going to fail, you need to replace or add more memory, add more CPU to this service. That kind of analytics the monitoring service provides. The logging service is like you can troubleshoot the things. If your algorithm fails and you want to know why it failed, you go to this logging service, view what is happening, and then fix the issue. So just a glimpse of all the services, but there are hundreds of services that are available. These are basically mostly used by the engineers, by the developers regularly. There are advanced services which the service providers which I showed you earlier provides, but those are like deep technology services. Come to next slide. So what is powering all this? What is powering this cloud computing? You know hardware, you know software, and what is this virtualization means? Again, virtualization is a software and which sits on top of hardware, which provides a hardware as a software. So you can, as I said earlier, right? You can swipe your card, buy your virtual machine, and you'll get it within minutes, right? So traditional servers, if you have to buy, you need to go to a dealer or a shop and buy. Tell him this is what my specification is, and he goes into his warehouse, gets you the physical machine, and you transport it to your office or to your home, and then set it up all the stuff, right? So instead of that, there's something called virtualization, which is which allows the hardware to be shared between different users in a whatever way they want. There's something called hypervisor that sits in between the hardware. This is the hardware, and this is the operating system. In between, there's something called hypervisor that is sits. It's not a pump. It's not. You should not consider it's an operating system. It's a piece of software that helps to virtualize, effectively utilize your hardware, shares the hardware between different applications. It can make your multiple applications run, multiple operating systems run in the same hardware, on the same hardware. If you see your laptop, what's the operating system that you would be able to run in your laptop or in your desktop? Basically, Windows OS or Ubuntu. But if you have a virtualized environment in your hardware, on top of your hardware, a software, you can run multiple operating systems: Windows, Unix, Linux, Fedora, Red Hat, or Solaris, whatever you want. So what's the advantage of it? Some applications run much faster in Windows. Some applications run much faster in Unix. Some applications leverages the advantages of underlying operating system. So if you have a single machine with single operating system, you are not utilizing the 100% of your hardware. It may be, some of the hardware may be sitting idle. For example, if you buy a hardware with 10 CPU, 10 GB of RAM, and 1 terabytes of memory storage, you definitely, if you're running one single application in it, you definitely will never be using the 100% of your hardware, whatever you bought. But if you are able to run multiple applications in it, you will be definitely using the complete effective utilization of it. Now there may be a question, without this also I'm able to run multiple applications, right? Even with a single operating system, for example, in my laptop, I'm able to run my video player, I'm able to run my games and everything. Then why this hardware? Why this hypervisor? There may be a question like that. The reason is all the applications. If an application is running high in the memory usage, then what happens to the other application? You usually feel that the whole software, the whole laptop is slower, right? So that's one of the advantages of having a hypervisor in between your operating system and your hardware. If one application is behaving bad, you can just throw it off, and then rest of the applications can still run without any issues. And some of the applications run much efficiently in operating systems of Unix and Linux. But you may not be able to use, as a developer, you may be interested in working only with Windows operating system. You can have your hardware use Windows as well as Linux in this hypervisor mechanism, in this virtualized world. These all virtual machines are sits in a data center on physical servers. So this is what the physical data center would look like: a typical data center with only the racks and then your physical machines in them, and then the entire software runs in it. A quick check: how is my audio and my speed? Is it fine? I assume it's
Yes,
good.
Yes, it is fine, sir.
Yeah.
Yes.
Yep.
Yes, sir. Yes, sir.
Yep. So thank you. Thanks for the confirmation. I just keep checking it because I may be going in my flow and things may not be right. Right. So Now you have seen about virtualization and the hardware virtualization. Now industry has come much more forward than that. They come to a containers called Docker containers. And containers is a technology, generic technology, and Docker is one of the open source community which is developing this technology. There are multiple technologies, like the Red has its own container technology, and Microsoft has its own container technology, and all of them. But Docker is one of the popular one. So now you saw that you are able to effectively utilize your hardware with keeping an hypervisor, and top of that, multiple operating systems running, right? So people want much more effective utilization of the hardware and much more secure way of running the applications. So having a complete full-fledged operating system running with a single application is not efficient, because operating system itself is a huge software, and running your application in that huge software takes more memory, more CPU, more RAM, and more storage. So it so what happens is